Emily Glassberg-Sands has been a strong supporter of WIDS from the start. I believe I've seen her at WIDS conferences every year at Stanford, and she joined the career panel at WIDS 2019. Last year, we were thrilled that Emily could give a tech talk at WIDS 2020 on data science and online learning and education. In her talk, Emily shares 3 examples of how data science and machine learning are used at Coursera. With the COVID pandemic, this talk is even more relevant now than it was a year ago. I hope you enjoy the talk.
Fantastic. Well, I'm delighted to be here today, and the Women in Data Science Conference is my favorite day of the year, really. So thank you all for staying through this afternoon. My name is Emily, and I lead the data team at Coursera. Any Coursera learners in the room? Oh, fantastic. More than imposter syndrome. I love it. So today I'm going to walk you through 3 stories of how we're using data science to advance education. But before I dive into those, I want to go back a few years, not to the goldfish that I used to be rewarded with, but to 2013. I was just entering the 5th year of my PhD program, and I'd flown out here to the Bay Area to interview with Coursera. The company at the time was small but mighty. There were about 40 employees only, but you could already tell that Coursera had the potential to dramatically increase access to education. And I was invigorated by the interview. I couldn't wait to start contributing, and so you can imagine my disappointment when the hiring manager called to let me know that they wouldn't be moving forward with my candidacy. The explanation was that the company was still really early stage, including in the data infrastructure and the tooling, and there were questions about whether someone with a background like mine, remember my doctorate was in economics, would be able to contribute. And the truth is the feedback was completely valid. I had actually come on site to interview for a role on the partnerships team and was handed off during the on-site to a group in engineering. I had no background in engineering. I'd never worked at a tech company before. All I knew was that I wanted to contribute to education. So this is Montfortin School. It's a small rural school in south of Bozeman, Montana. It's my school. And this is Forest Park Trailer Park, where many of my classmates lived. A couple days a week, I was pulled out of class to be put in what's called the Gifted and Talented program. And I remember going home to my parents and saying, but isn't everyone gifted and talented? Why do they have to pull me out? It's really embarrassing. And my parents' answer was, yes, everyone is gifted and talented, but not everyone has had access to the same opportunity. At 18, I left Montana and I went out east for school, and I became obsessed with understanding the sources of inequality and, more importantly, what we could do about them. In New York, I met this incredible playwright, Julia Jordan, who was convinced that women have a harder time getting their plays into production. And I proceeded to spend a year working on observational and experimental studies to understand whether that was in fact true, and if so, why. In one example, Julia and her friends wrote 4 scripts for me that had never before been seen, and I sent them out to hundreds of artistic directors and literary managers around the country, varying only the pen name on each script. So is it purportedly written by Mary Walker or Michael Walker, and asking if they were interested in putting the play on stage, and if so, why. And what I found is that unfortunately there was discrimination in playwriting. The exact same script, when purportedly written by a woman, was less likely to make it onto stage. But as important, I also found out that the theater community cared. They wanted the best plays to be in production, and this insight spurred change. In graduate school, I continued to use data to understand who gets access to opportunity. I was shocked to learn that over half of jobs are found through personal networks. Well, referrals are valuable in some ways, but they often come at a cost in terms of diversity, because people tend to refer people who look like them. So I ran a series of field experiments in an online labor market to understand why firms hire referred workers. Are referred workers really that much more productive on the job, or is there some nepotism at play? So it's the same fascination with understanding opportunity, who has it, what we can do to expand it, that led me to want to work at Coursera. And lucky for me, eventually I convinced the hiring manager to change his mind. And today I lead the end-to-end data team across data science, data engineering, and machine learning, working on building a better product through data. What excites me most about data science is the opportunity it affords each of us to contribute to the problems we care about most. I'm going to share 3 stories today of how we're using data science to solve problems in education. The first is about helping learners stay motivated and on track. The second is about helping teachers better support those learners. And the third is about ensuring individuals have the skill signals they need so they can be rewarded for what they know in the labor market. So let's start with the first. A big problem we see in learning is retention. This is true both on campus and online. At Coursera, only about 1 in 5 active enrollees go on to complete the course. Now, not all of the drop-off is bad. In some cases, learners say, hey, I got what I needed in just the first couple modules. But in other cases, learners drop off because they lose motivation or because they're stuck on an assignment. And these are barriers that we can break down. 2 years ago, my team landed a feature called In-Course Help. So it's a system of personalized learning interventions that reach out to a learner as she's moving through her experience and support her in staying on track. Here's an example. When a learner first enrolls, she's encouraged to get started with compelling statistics, like how much more likely she is to complete the course if she starts in the next hour. As she's moving through, we reinforce her progress, like reiterating the value of incremental learning. And when she looks stuck, we can help her get unblocked, like recommending the best review material for her based on the area she's struggling with. Different learners, of course, benefit from different messages. And so an Explore Exploit ML system can help ensure we land the right interventions for the right learners. We start with this pool of potential message variants. So the getting started nudges are one, review materials another. There are many versions of these which can be served at hundreds or even thousands of places within courses. We run all of those through a message level model that understands, on average, will this message be net positive for learners, and decide which to include in our product. From there, we take each combination of messages and learners and run it through a learner level model, which incorporates features of the individual, largely behavioral, as well as of the message, and decides which are most valuable for her. With the remaining probability, we randomize whether or not learners receive messages, so we have a fresh and unbiased source of training data. And then for each of the now nearly 100 million interventions that we've served, we see downstream behavior. Does the learner choose to engage with the message? Does she report it helpful? Does it have an impact on her downstream learning outcomes? And these learning behaviors feed back to power both. This was designed, developed, and deployed in the summer by an intern named Marianne Sorba, who's looking at me with crazy eyes right now, but really fantastic work. In some cases, we can also use machine learning to create the message variants themselves. So take the case of wanting to recommend review material for a learner struggling with an exam. To start, we collect training data from instructors and ask them to tell us what's the best material for a learner struggling with this question. Now, we have about 300,000 questions on the platform. Instructors don't have time to tag them all. They've only tagged about 5%, but we can use that as source of truth in a predictive model where features of the model include, for example, semantic embeddings as well as learner behavioral features. So when learners failed this question and went on to review material, did they end up being successful in the question later? In order to predict for the other 95% that haven't been tagged, what's the review material we should recommend? Personalized learning interventions like these are driving double-digit increases in the rate at which learners progress and complete content. They break down barriers, both behavioral and pedagogical, through the learning experience. But it's not just in education where these methods are relevant. In healthcare, less than half of Americans follow doctors' orders in taking their prescription medication. In personal finance, about a third of Americans have saved less than $5,000 for retirement. And by building personalized intervention systems, be it in education or in health or in personal finance and beyond, we can start to better support each individual in making the best decisions for her future self. Fully automated interventions are in many cases sufficient to support learners, but once in a while we all need a little human touch. Does anyone here have children at home? A good share. More than at most conferences. This is Tucker. He's my 8-month-old, and between work and Tucker, I'll admit to not having a lot of time for other things I care deeply about. For example, much of this talk was written from the mother's room at Coursera. And so I can only imagine what it's like to be an online degree learner, the vast majority of whom have a full-time job and have a family and are also layering on top a full degree program. One of the things that can really help is human touch. An enrollment counselor that reaches out and asks why you haven't logged in, a TA or tutor who provides support on a particular assignment. But in order to provide that human touch while still keeping the cost of our degree programs low, we need to do everything we can to make that human support really efficient. Last year, we built this feature called the Student Support Dashboard, which for all degree learners is predicting what grade they're going to get in their currently active courses, and critically includes human-readable insights for why at-risk learners are at risk. The underlying predictions are unique in a few ways. First, our courses are all very different, and so we have to train course-specific models. Second, we have to deal with the cold start problem, so a lot of degree courses are being offered for the first time, and we have to dynamically identify what is the right training set to use for those new courses. But I think most interestingly, we need to provide these human-readable insights for where the predictions are coming from. So let's dig in a bit there. To start, our feature engineering focuses on student activity features, and there are kind of 4 big buckets, which I've included up here. We could include features to improve, say, the accuracy of the model about the course itself, or features about the student's demographics, but these are much less actionable for support staff to use in reach outs. From there, we need to understand, for any given learner, if we were to permute her value, for example, to the median, would it meaningfully impact her grade? If so, we serve up these human-readable insights included with the prediction. So you could take the case of 2 different learners. Both are at risk of failing a course. One learner is at risk because she hasn't logged in for 14 days. She's very likely to benefit from a reach out from an enrollment counselor. But another learner is consistently logging in and just failing the assessment time after time. She really needs help from a TA. At Coursera, these at-risk models, again, coupled with the human interpretable insights, allow us to provide that human touch at low cost while still keeping degree programs well priced. More generally, machine-assisted solutions like these can accelerate professionals from radiologists to career counselors in supporting others and using their time efficiently to do the work that only humans can. Once we get learners successfully through the learning experience, we also need to support them in being rewarded for what they know on the job. There's a lot of folks out there who have the required skills for open roles. We've heard from a ton of people in data science who don't on paper look like they would be data scientists, and folks who might not look from a traditional resume based on where they went to school or what they majored in or the past jobs they have, often have the skills required to do the job. And this is becoming increasingly true as we're moving to a world where people are learning throughout their life. So the old model of learn, do, retire, only my credentials from the beginning mattered, is no longer the world we live in, right? We saw this room, so many of us are investing in learning throughout life, and we need to be able to signal that to the labor market. Relying exclusively on traditional resume signals doesn't just make the labor market inefficient, it actually makes the labor market unfair. And the reason is that people who have access to traditional credentials generally are people who are of higher socioeconomic status. So the World Economic Forum recently released this report. They're basically calling for skills as the new currency in the labor market. And included in the report is Coursera's skill scoring offering, which I want to touch on briefly. Skill scoring is aimed at creating more clear signals for individuals to understand their skills relative to their target career, and for companies to understand talent. It's an application of our broader skills graph, which is a data asset we've built out at Coursera over the past few years. At a high level, what we're doing with skills graph is we're taking a robust library of skills and we're connecting them to each other, to the content that teaches them, to the careers that require them, and to the learners who have or want to have them. Skill scoring starts with understanding what skills are taught in each unit of content. So instructors and learners, as they're moving through content, are tagging skills to courses. Many of you may have seen a pop-up that said, "What skill are you learning?" Thank you for answering. Of course, learners and instructors can't tag everything, but we can use their tags as a source of truth with natural language processing-based features to predict for all other content what skills are being taught in any given unit of content. From there, we can measure what skills each learner has based on her performance on all of the assessments she's attempted on the platform. But for a given skill, say statistical programming, how can we get from tens of millions of attempts across hundreds of courses and millions of learners to a reliable estimate of each learner's skill score? So to start, here are 4 desired properties of our solution. First, we need the algorithm to produce stable and reliable estimates even in the presence of time-varying skills. We're learning because we want to be developing our skills. The expectation is the skill is changing over time. The algorithm needs to support that time-varying component. Second, since our assessments are spread across hundreds of courses, we need to account for selection effects, where in particular, higher skilled learners are more likely to attempt harder assignments, and we don't want to penalize them for doing so. Third, we need updates to learner skill profile to be explainable. So as your skill score evolves, you should understand what's happening under the hood. And fourth, we need the updates to be computationally feasible across millions of learners and thousands of courses, including in the online context. So when you submit an assignment, you should be able to real-time see the evolution of your skill score. Any chess players in the room? Oh, I get the semi-hands. Good. I knew we'd have at least a few. So for skill scoring, we built out an adaptation of ELO and related rating systems. These are often used in chess, also for rankings in team sports. I could have asked any basketball fans in the room. We treat each learner and assessment item as players in a tournament. So every time a learner attempts an assessment, it's considered a match. And this is a summary of how the skill updates work. So mu is my initial score, and mu primed is my updated score. Correspondingly, sigma and sigma primed are the baseline and updated levels of certainty represented in standard deviations. And then the values with subscript O are for opponent. S is the outcome of a match. For a learner, if I pass the assessment, I win the match, so S equals 1. If I fail the assessment, I lose the match, so S equals 0. And you can see the explainability and computational simplicity of the updates. So if I come up against an assessment that's harder than my current skill level, and I pass it, then my level increases. And very simply, that change in my level is just a function of the prior on my ability, the prior on the difficulty of the assessment, and the level of certainty in each. Learners use skill scores to, among other things, understand how their skill profile compares to folks in their target role. So for example, of data scientists on Coursera, what skills do they have? And therefore, what do I need? And what learning can close the gap? In parallel, companies are starting to use skill scores to identify talent well-positioned for new opportunities. For example, of back-end engineers, who has the baseline math to be able to transition to a machine learning role? So as any labor economist will tell you, people pursue education for two reasons. The first is to develop human capital or skills. And the first two case studies, personalized intervention system and interpretable student at risk models, are really designed to support that human capital development. But the second reason that we pursue education is to have a valid signal in the labor market. So we can be in the job that's best positioned for what we know and realize our full potential. And that's what SkillScore is aimed at accomplishing. Stepping back, the world is changing at a faster and faster clip, driven primarily by technology and globalization. I cribbed this from Thomas Friedman in his most recent book, Thank You for Being Late. He talks about how the rate of technological change is exceeding the rate at which humans are able to adapt. And this is creating serious dislocation for many people. We need to, he says, bend that curve of human adaptability. We need to learn at a faster and faster rate, and not just you and me, but billions of people around the world. The good news is that data and technology can also be part of the solution. And that's why I feel so lucky to be both a data scientist and a Courserian. All too often, there can be a disconnect between the data science work and the impact. And so I hope that the story shared today, not just about Coursera, but throughout the Women in Data Science movement, can remind us all of the impact we can have through data science, because it's incredible the products and services that we can build to make the world a better and more equitable place. Thank you.